Welcome to Robotics at the Edge, breakthroughs from cs.RO papers. Today we explore intelligent machines as featured in 24 cutting-edge robotics papers published on June 5, 2025. Discover how robots are learning, adapting, and collaborating in new ways, from self-assembling coffee tables to health monitoring wheelchairs. Our focus includes technical, societal, and human-centered advances, with special attention to our paper of the day, Fabrica by Tien and colleagues. How close are we to robots that adapt like humans? Imagine a world where robots assemble furniture or monitor your health in real time, learning new tasks without any human guidance. Robotics is advancing rapidly, and today's papers reveal remarkable progress toward these visions. Join us as we unravel the next chapter in robotics innovation and ask, just how near is this future? Why does robotics research matter now? Robotics merges computer science, engineering, and artificial intelligence, producing innovations that impact homes, hospitals, factories, and disaster response. The cs.RO category signals research where software meets real-world action. Today, we explore how 24 new papers redefine robotic intelligence, spotlighting key themes, breakthroughs, and a standout study to frame the state of the art. Let's overview the field. cs.RO stands for Computer Science Robotics, a multidisciplinary intersection where engineering, hardware, algorithms, and learning operate in harmony. Picture a concert hall. Robots sense, decide, and act in unpredictable environments. Advances in robotics spill over into areas like artificial intelligence, computer vision, and human technology interaction. Robotics is where the orchestra creates the music of movement, an interplay of hardware and intelligence. Theme 1. Integrated planning and learning in robots. Modern robots are now able to plan and learn simultaneously, akin to chefs who adapt recipes on the fly. Tien and colleagues' Fabrica system exemplifies this. Dual-arm robots assemble previously unseen objects. Modular planning breaks complex tasks into manageable steps, while reinforcement learning enables robots to improve through trial and error. The metaphor shifts. Robots are becoming creative problem solvers, not merely rigid machines. Theme 2 focuses on data efficiency and sim-to-real transfer. Robots now learn faster through smarter datasets and advanced simulation strategies. Systems like Active Pusher and OutVIP demonstrate efficient learning, reducing the need for extensive real-world trials. The principle of equivariance allows learning to generalize across diverse shapes and orientations. Sim-to-real transfer bridges the gap between virtual practice and real-world success. Much like training on video games and excelling on an actual bike. Theme 3 explores human-robot interaction and bio-inspired design. PulseRide, from Wang and colleagues, is a wheelchair that adapts in real time to a user's health. GEX, developed by Zhou and colleagues, features a robotic hand and exoskeleton glove for teleoperation. Soft, pill-bug-inspired robots can squeeze through tight spaces, advancing flexibility and resilience. The focus is on making robots more user-aware, serving as health partners and nature-inspired helpers. Let's highlight key findings from the robotics frontier. Fabrica by Tien and colleagues achieved an 80% success rate in assembling unseen objects. Kim and colleagues showed that synthetic data can significantly improve robot soccer detectors. PulseRide users spent 71% more time in healthy activity zones and experienced less fatigue. GEX democratizes access to high-quality demonstration data. Each advancement brings robots closer to tangible, everyday impact. Our paper of the day is Fabrica by Tien and collaborators, a new era in robotic assembly. Fabrica aspires to enable robots to assemble almost anything unaided. The dual-arm system scans, plans, and constructs objects without human input, addressing both industrial and daily assembly challenges. This work is driven by the need to eliminate labor-intensive, object-specific programming and sets a new benchmark for generalization and adaptability in robotics. How does Fabrica work? The system employs a hierarchical planner to decompose tasks into order, grasp, and motion subtasks. Equivariant policies enable generalization across a variety of object shapes and orientations. Residual actions continuously refine robot motions in real time. Lightweight reinforcement learning is applied for adapting to intricate assembly steps. Notably, there is no handcrafted knowledge. All policies transfer directly from simulation to reality. Fabrica's impact is significant. It achieves 80% real-world assembly success across diverse objects. Policies transfer seamlessly from simulation without manual tuning. The project is motivated by researchers' desire for adaptable robots that require less constant supervision. Fabrica overcomes long-standing challenges such as object slips, sensor drift, and simulation mismatches, opening new possibilities for factories, domestic robots, and disaster response applications. Looking ahead, robotics is evolving into a living ecosystem, much like species in a rainforest, diverse, adaptive, and resilient. Simulation and synthetic data function as nurseries for robot training, allowing for scalable, risk-free development. Human-robot partnerships are becoming increasingly important, with robots that sense, learn, and assist. Advances in bio-inspired materials promise greater resilience and efficiency. Ongoing challenges include adaptability and explainability, marking the next phase of robotics. In conclusion, robotics stands at a crossroads of innovation. The cs.RO domain unites planning, learning, and real-world action. Key themes, data efficiency, robust control, and human-robot synergy are driving progress. Breakthroughs like Fabrica, PulseRide, and GEX are redefining possibilities. The underlying methods, reinforcement learning, modular planning, model predictive control, and human-in-the-loop learning constitute the toolkit for the next generation of intelligent machines. Explore, question, and help shape the future of robotics. This presentation was synthesized using GPT 4.1 for summarization and narrative structuring. Text-to-speech audio was provided by OpenAI, and visuals were generated with Stable Diffusion. Human experts have reviewed the content for technical accuracy and clarity. However, some oversights may remain. For comprehensive details, please consult the referenced works, including those by Tien, Wang, and Zhou. All cited studies are referenced for further reading. Subscribe to AI Frontiers for deep dives into artificial intelligence and robotics. Stay informed about the latest breakthroughs and expert insights, and join the conversation to help shape tomorrow's technology. Channel AI Frontiers. Thank you for exploring the future with us. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the archive preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses archive preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by Archive Preprint Server.